Hello, Dr. Mike here. This is for my Cybersecurity version 2 playlist, and this is a topic on access control and privilege management. Is with the new textbook, chapter 14 of the same name. And as like my other videos, I'm actually going to cut to in a minute here the previous version 1 cybersecurity. Really not too much has changed in this topic. I will cover some changes you see here in the chapter, which is some good stuff though. Privilege management, what it is, server use, group management. It makes sense to add people to groups. One of the biggest examples I can probably think of is you have developers and we have testers. And so you want to be able to share stuff back and forth. So we want testers to be able to read only developer code, and developers only read only test procedures. So we don't want testers to be able to change code. If they find a bug, we don't want them to go in and just make the fix. We want that to be done officially through proper channels like change control. And you don't want developers to go in and change test procedures so their code passes. So group management, read only, read write, and so on. And you'll see that used a lot in a lot of places. And you see this, of course, in Active Directory, in Linux, directory permissions, group permissions. And so this talks about it in Windows, domain policies, and so on. Talks about passwords. I'm not going to talk about that. I think we covered that before. But there's a good section about password construction. But there is something here added about single sign-on. This is both good and bad, you can say. If you implement poor single sign-on, where you don't have this things in, you don't enforce a good password history, aging, minimum password lengths, and so on. Maybe you have multi-factor authentication. What that means is I sign in once to some sort of authentication portal, but probably let's say a website, and from there I can launch into other apps. So maybe I can launch, for example, at the school I launch into my Sinclair, my college's main site, and from there I can authenticate, single sign-on. It does it for my LMS, Learning Management System, and also into other things, maybe the online lab system. And since I don't have to log in again, it makes ease of use great, and that's an important factor when it comes to security. Problem is if they have really weak password securities, weak passwords and so on, someone gets that one password, gets that one account, they can single sign on to everything. But we've seen before, if you don't have single sign on, you have 4 surfaces here. Each one has its own user ID and password. The administration overhead is times 4, maybe times 3. The administration overhead is a lot more, and then users have to record and track passwords. So they use the same password for the same services anyways. Maybe they write the passwords down. So there's other weaknesses that inherently come from not having a single sign-on. It's going to be a risk versus reward thing. You have to look at the cost of it, ensure it's properly set up. So important to understand what single sign-on is. Other things you can do, of course, time to restrictions, settings on login hours, and so on. Token use. So as we get into read-write permissions here, we've seen this before. We see this in the next video, so I'm not going to cover that here. Windows rights, access controls. Now, so access controls here. Now we get into the actual types. And here's where we're going to take off. Another video will cover this. So I think everything else here in the video, Bell Alpadura, Biba models, and so on, all discussed in the current video. Just the last note here, auditing is a huge thing. You gotta make sure you can audit and have those internal controls. So everything here in this rest of this chapter is covered in the video, which will start here, coming now. What is access management? It's giving access for somebody. So you've already gone through the authentication part, whether it be multi-factor, password name, whatever. You've proven who you say you are. Here's who you have access to. And it can be physical, but we're going to keep in the terms of computing. But yeah, I mean, it can also consist of locks, man traps, things like that, things that help limit access to a device. So I like you to think about access control as also a few areas. How you administer it and how you audit it. It's very important. So there's some aspects we'll look at there too. So technical access controls, these are things again on the system itself. Active Directory, for example, only give you access to certain functions of your operating system. So Active Directory being the technical control. So some more terminology here. ID, authorization, accounting. So that's the new one I'm bringing here, I think, in this slide. We're going to bring in the word accounting here. Not in the sense of accounting with, as you think it is, more like auditing and accounting. So we need to make sure access is logged and can be traced back for a lot of reasons. So again, record of user actions. What does someone access? When do they access it? How they get in? So this was referred to as logging on our computer systems, logging of all kinds of access. Very important. Have an audit trail for forensics work, for certification, maybe for ISO certification. So let's look at some terminologies here. There's a few things we'll look at here. There's something called an object. This could be a file, it could be hardware. Think of it in terms of a file. And there's a subject. Now we think the subject is a user, but it also can be a process. An example of this is the Apache process on a Linux web server. Apache itself runs under a user account, and it has specific access. Then we have an operation, such as read a file, for example. And of course, we have some terminology here: officer, custodian, owner, and user. These are more examples. A privacy officer has access to a salary XLS with the duties. So I'm going to skip over that one. But it is important to understand with this slide and the previous one is that when it comes to access, people grant access to other people. And it could be cause problems. So we'll see here in a second where that could become issues. Where it becomes an issue is this. Our access control models. So the first one, discretionary access control. This is basically saying we have user, here's user Bob, and here's user Mary. Bob has access to, and this is what the slide shows you, this XLS file that contains sensitive data. Now he uses authentication to get into his account, and he has authorization to view and access this file. Now under directory access control, he can copy this file to a public folder where Mary can get to it. Mary can log in. She has used proper authentication credentials to get onto the same system, so she's allowed in this area. But she's not supposed to see this file. But because of the act of copying the file or giving access to this user, using like the Windows ACL list on Windows ACL, or just our DAC controls, we know our permissions and ownership, and permission ownership in Linux. This could be inadvertent. User Bob makes it read access to the world. Both either an ACL or an access, and Mary then can view this document. So this is what DAC has weaknesses. The weakness itself is here is with the person. This person can do something to this, either accidentally or maliciously, to allow inadvertent access to that resource, that object. And DAC is what we normally have with Linux and Windows, your normal standard controls. So how can we go and handle those? Well, this is where we look at Mac, mandatory access controls, and role-based access controls. There's also rule, which I want to touch upon, and there's some attribute-based controls too. We're going to focus really on Mac here in a second. And again, with discretionary access controls, the owner has rights over the whole object. Again, and we see this cause issues. I think I just already talked through the slide in my example. I'll leave it for a second. So again, you can see here, owners could give permissions to the user, subject, and object. That's probably the main thing. They can basically bypass what would be normally considered maybe confidential data given to a person who shouldn't be able to see it. Again, with our ECL here, they can modify this. Now, where does Mac come into play? So Mac adds something, think of tags, something called labels and levels. And it builds what's called sort of a lattice control. And I'm sure I'm going to tell about the Bell LaPadula model. It's probably referred to in the chapter. This is the basis of this. And it's also called BIBA integrity model too, but I think it's the Bell LaPadula that is what we look at when it comes to what Mac comes from. So I'm going to give you a quick example, and I'll dive down and show you the actual lattice model itself. So I'm using something called SE Linux. SE Linux is it comes built with Linux, and usually it's turned off by default. I think it depends on what the current distribution is. Red Hat has it. It comes in all flavors of Linux, and it enforces its labels and types, and it sort of has its own little security server, and it grants permissions to something. I'll show you what that means. So let's just give you an example of this. Again, think SE Linux. You can definitely look at this. You can Google SE Linux and find information on that. So how does it work? Let's give you an example here. We use a Linux systems, a Linux laptop. And so I'm user Dr. Mike here, logged in. As you know, Dr. Mike, we have our own home directory. Excuse my really bad scribble there. So in here I have, let's say, a copy of Firefox browser. I have Firefox installed. We know Firefox has some sort of called dot or hidden files in my home directory. Cache, for example, add-ons, things like that. Also in my home directory, I have a .ssh directory. In there I have my public and private keys. My public key and my private key. So this is my Firefox browser. Again, it's going to use, for my user, it's going to have local access to a hidden directory, again, cache and stuff like that. And I intermittently load a bad add-on, or add-on I think it's called for Firefox, or extension. This extension is going to go through and it's going to harvest information from my home directory, and it's going to send it out to the world. And inadvertently, it's going to expose my private key that I use for SSH as part of that. So, which is bad. Private key being leaked out is a really bad thing. My secure shell integrity is now shot. But how to do that? So under normal circumstances, I run Firefox as user Dr. Mike. If you were to bring up a process list, the process for Firefox has an owner, and the owner is Dr. Mike. The directory of Dr. Mike, I can read and write everything because I am the user Dr. Mike. So this inherits Dr. Mike. Let's put Mike there. All right, so see Dr. Mike. It inherits the ID, let's put that, the ID of the user that ran it. And because under DAC, this ID has full access to the home directory, including SSH. Okay, you see where that's bad, right? Now, what does a MAC control do? So MAC control hangs a tag on things. And SE Linux, it's a label. And this label itself has access here. And there's a rule base here, so we're going to use SE Linux, has that sort of has that control infrastructure that's built in. And we have rules based here. There's a rule here. So hanging on this tag, SSH directory, is a tag for SSH D, which is a daemon for SSH. That sort of ownership of there is hanging on this. When I'm on Firefox, even though I'm running as Dr. Mike, it has, maybe it has a browser, or let's just give it a Firefox tag hanging off it. So what a Mac does is, when this malicious extension goes in and says, I want to read this SSHD directory. SE-Linux does a check and says, wait a minute, you're running with the tag of Firefox. Only the tag of SSHD is allowed to read this .sh. So it sort of sandboxed it, and it's going to deny it. So again, it checks the user, and checks the tag. So first the user check happens. This is DAC. Of course, that passes. This tag is a MAC, or Manager Access Control. It does not pass because the tag of Firefox is not allowed to read the tag, anything with the tag of SSHD, which then will block that. So, other places would the defense would be with shell shock, for example. The shell shock, actually, SE-Linux would defend you against a shell shock. Now, again, you should patch. That's not, but this would be a further implication of that. So, SE-Linux has some, I say from experience, has some things about it. It has some complexity. Actually, my entire doctorate dissertation is based on dealing with the complexity of SE-Linux. I'm not going to read that to you right now. I'll put you to sleep. So that's the big element with Mac. Mac has this matching labels. And really think about it as a need to know. In Firefox, you don't have to need to know anything in SSHD directory, so I'm going to block it. And so that's what happens with that access. Now, let's look at the more Bell LaPadula lattice look at this with labels and levels. That's this lattice model or rung lattice model. That's right here, the Bell LaPadula model. So a lattice model, based off what we have is levels and categories. So let's see, there's an example here. All right, probably not. So we'll just do our own here. So we have a level we assign to our objects. Most commonly say is top secret and secret. Keep it simple. Do a simple lattice. We'll do two of them. And we have categories that a subject can belong to. So again, level it's assigned to an object. A category is assigned to a subject. So think of the category as either, let's say, Army and Navy. Now with this, we could build out sort of access control. So we can either say, well, we have top secret that can be accessed by both Army and Navy. Based on that access control right there, there is top secret that only the Army has access to. There's top secret that only the Navy has access to. And then there we have the, so based on that again, so top secret, if you have top secret Army, Navy, if you have this assigned, you can access top secret for Army or top secret for Navy. But only that way. You can't go the other way, right? So I can't, there's no crossing of the streams here to bring a Ghostbusters term into play. So we also have secret access. So we have secret for Army and secret for Navy. So there's some inheritance with this. If I have top secret for Navy, I automatically can read secret for Navy. If I have top secret for Army, I can read secret for Army. If I have top secret for Army, Navy, I can also read secret for Army, Navy, right? I can read down to the lower level. But you notice here is there's some breaks here. What if we assign, this is again a lattice here, or layers, right? If someone has only assigned secret to Army, they can only view secret to Army. Let's see, I get a different color here. So they can only view this. They cannot read up. There's no reading up. And if someone tries to share that, they will not allowed to share that. There's no reading down either. So I can't share something I don't have access to. I can't share something, almost like with SE-Linux, you can't read something you're not allowed to have access to. So if someone has assigned this level and category, secret Army, only secret Army. If someone has top secret Army, they can only read this. They inherit the secret, but they also get top secret. So user 1 here can only read subject 1 is assigned to a secret Army. Subject 2 is assigned to top secret. So they get access to both. Again, they cannot read up. There's no read up here. They can't write down to this user anything. I can't then share top secret to this person. It's blocked. So we just sort of fish that out. Then, of course, if I have if object, in this case subject 3, has this, they have access to everything. So hence, this is the rungs here. This rung or lattice model. You can draw it as a matrix. You can draw it as rungs, but you can see here there's a subject 1, subject 2, and subject 3. So again, use something like SE Linux is a way to go and do this, along with DAC. So it's sort of to go hand in hand, along with maybe Active Directory. You can put these into place. That's the Bell LaPadula model. Been on for a while. And again, I think I most already the Mac identifiers, tags. We see this in Windows called UAC, User Access Controls. We see this, right? You want to allow this thing to make changes. In this case, we see this a lot as an individual user. We have an app that has been launched that wants to make changes. The app itself is not the user, even though it runs within the user account. UAC says it's going to ask for permission. In this case, we sort of allow it. Hard line would be no, don't allow any access at all, which we know does not work if you're a Windows user. You can't install anything. But you can see if you turn that on, though, any kind of malware that wants to go ahead and run, it's not going to be allowed to run because it's blocked by automatically. Or in the case of a standard user account, I download a Word document and this pops up. Whoa, wait a minute! I don't have any. Why does this Word document need to make access changes or make control to my management console? So it blocks that attempt. So again, it's need to know. Same as my example with the Firefox malicious add-on or extension. So role-based, sort of taking it to the next level. This makes it easier to, instead of individually creating a special Mac setup or Active Directory setup, you assign roles. The role of top secret general, for example. General gets top secret, and so automatically that role gets top secret. A general gets top secret, and then the general roles, these subjects are generals or admirals. They belong to that role. So it makes it easier to manage. As you add this complexity, this role-based access control gives some help to manage that complexity because users come and go. And it's important to be able to ensure a user has the proper access. So rule-based or role-based access control, you can also add rules to it. Only certain times of the day can be accessed, only from certain IP addresses, certain networks, and subnets. But rules give some flexibility, and they take advantage of attributes you can assign to that. So, and also with ABAC here, you can do some if then else. So we can deal with the complexity of having to apply business security from the business side or the military side, or whatever you want to call it, and put it into a technical control. So there's an example there. The attribute base is very flexible. Rule-based or role-based. More real world is what would be the role-based access control. Simple example of this, you go into the college, you sit down, you log into the desktop provided by the school, and of course you authenticate, username, password. That is authenticated, done, and then Active Directory has a policy, which is a role-based. Your role is student. Student has access to these functions on that desktop computer. If you're IT support, you come in, you log in with your credentials, you're given different access to that computer, probably full administrator access on Windows, for example, because your role is IT desktop support. So you can see where the role base is really going to be a real way to apply these more discretionary and manager access controls. So a couple things to go through too is of course, properly configure accounts is strong security. This goes back to my previous topic, chapter 11. Again, you need to make sure accounts are hard to get into. So account management, also auditing. This is very important. You need to have record of when someone does log into a system, when they're accessing a system with certain credentials. It could even be to the level of the object itself. When someone opens a file, that file is then logged somewhere. This could be from really more a lot more stricter security, but you can see where you need to have an auditing trail. And of course, the account manager comes into play, and accounting comes into play. A couple things, of course, is we initially set up an account, location-based. There's things that might have rules. Maybe this person's only allowed to log into this desktop under certain times of the day from a certain IP range. So again, there's a lot of things that can come into this role-based or rule-based access. But the biggest one is this: least privilege. Just don't give anyone full admin privilege, even if you're not sure. It's always least privilege. So least amount of access needed to complete the job. That's very important. And as a professional, if you do security audit, you look at maybe the access for test environment, and all developers are given full admin control. And of course, that can be bad. Because if someone gets their account hacked or they run some malware, their machine has access to this server that has full admin control. You don't just open up and give more assets to an attacker, a stronger foothold per se. So least privilege is very important, and usually comes into conflict with easy use. You'll get the I'm a software developer. This is a development server. I just give everyone admin control because we're just developing the rough code here. Of course, production servers have all the proper stuff. You can't let that fly too much because that development server gets forgot about. It doesn't get proper auditing, doesn't get proper once over from security, and it becomes a very low-hanging fruit target for an attacker. So onboarding. Again, when an employee is onboarded, this is the time you go through the rules, you make sure you verify what they have access to, socializing, workspace cleanliness. There's stuff. There's a more administrative than is technical here. Job duties need to be explained to new employees, especially if it's a high security. One example is maybe don't have passwords on Post-it notes. Some places that could be a fireable offense. You need to have HR be able to enforce these rules, and it's for the good of security. So it goes beyond just technical aspects. There are administrative accesses here, and that's usually best places when someone is onboarded. That's the best time you want to go ahead and go over these. And usually it is. If you've been a new employee anywhere, you go through training. You got to read the password policy, watch a 2-minute video, take a 2-minute. The 3-question test, pass it. And these things, they seem silly, but they leave a trail of "we told you so," and you acknowledge that you weren't do this. And also us, we can verify that you have the proper access to get your job done. We don't want to give an employee no access, and then their first week of their job, they can't get their job done because we haven't set up correctly. So it's best times onboarding. Provisioning, the same thing here. Offboarding is very important too. When someone leaves the company, whether it's voluntarily or involuntarily, there should be steps you do. First off, you usually don't just delete an account. You don't just delete an employee's account. You usually, like going to Active Directory, you'll sort of mark it as no longer valid, or there's a flag in there to sort of show them as an inactive account. You want that database entry of that information for that account because it can be traced back to access logs. So imagine an employee leaves on their own will, but we have their HR database here. I'm using red again, I guess. And this employee has accessed these specific resources. Maybe a server up here, maybe they've accessed a file server, a database access here, and something over here, they've done something malicious. Maybe they've stolen data, or they deleted something here, maybe they've stolen data from here. And these logs say, well, employee number 1, 2, 3 is stamped on these actions. Well, if we delete this, delete it, get rid of it, we have employee 1, 2, 3 now, but we lost the other part of the clues here, right? Our evidence. We don't know who they are anymore. What was their address? So it makes sense. Again, you don't delete that record of the employee. You sort of mark them as no longer valid. And also, if they have any accounts out here, maybe they have access. Employee 1, 2, 3. We've unbeknownst they have access to an external resource. Let's say a GitHub, a Git repository that sort of fell out of this offboarding thing we forgot about. Well, if this Git repository does a check, maybe a SAML check or some other way, and it sees that 123 is no longer allowed, now we block that access. So offboarding, it can be a very technical process, and it has to be done correctly because you can leave holes open. You can lose information. You can leave things open that you don't want to leave open, especially for these third or external accounts, GitHub, any kind of social media accounts, maybe that are company driven, anything like that. Blog pages, things like that the company has that are run through third parties that still have that account active. So, and that's these orphan accounts, and that's what you want to watch out for. Again, location-based policies, I talked about this already. Time of day policies, there's ways to set this up. I'm not sure where this GUI came from, but this isn't a textbook. And it makes sense maybe for high security. Probably the most important is least privilege. If someone comes in and they're just a tester, and they need read-only, you give them read-only. If they're a developer, they need read-write, you give them read-write. And this is where role-based really helps out with this. And again, very important. Auditing is very important, and that means logging, and that means logging not just at servers, logging not just when someone logged in, maybe logging what they had access to, logging when they had their keys rotated. I say keys as in like security keys, like SSH keys used for cloud access. So auditing and review is very important. Some of the things too, that, again, this goes into not just, it's not technical, this is really a business policy, separation of duties. Don't give accounts receivable access to accounts payable. It's been one of the basic examples that's used for accounting, for business security, financial security. I don't know a person that can write a check and authorize myself to cash my check. Separation of duties, it comes in all places. You can probably find it. And maybe I allow testers to read the code so they can test it, but I don't allow them to write to it. I don't allow developers to write to test cases because I don't want modifying them so their code passes. Mandatory vacations, that's a great one. Clean desk policy is a good one though. Job rotation, it's going to depend. A lot of times it's good just to maybe have certain people in certain positions try different jobs out. That's going to be a dependency. And the mandatory vacations, yeah, I never really heard any company making any take vacation. But it's good to maybe make sure people take their vacations. You don't want to have employees go sour. But clean desk policy is the one you definitely could have. You definitely want to have that. Yeah, employee burnout. Yeah, clean desk policy, lock cabinets. This gives you just a visual walkthrough of an office space. Very important that you don't have that post-it note with the password on there. And again, implementing access control lists, group access controls. There's a lot of ways you can do this. Chapter gets into how we can actually do these. Windows ACE structure, I know Active Directory. There you go, Active Directory. That's the one that comes to mind. With group policies, local group policies. And we have entire server stacks. And the chapter's going to go into the details of these. Definitely go back and read into these. I'm not going to make this any longer by going to every little thing. But there's Radius, Kerberos, TACUS, TACUS Plus, LDAP, SAML, and of course Authentication Framework protocols. Definitely want to make sure these are in place that can help enforce these. Also make sure those are secure. You don't want those to become a source of a target, or someone can go in and maybe hack into the LDAP server and get or modify credentials, and then maybe cause a vertical escalation of access, which is a hack, of course. We don't want people to do that. So we have all these protocols in place, password authentication protocol, SAML. Again, these are protocols and make sure they're set up and running correctly. Again, the chapter is going to go into how these work, these different servers work. I don't know if I want to go into that. I'll look at the summary about those in a second here. So that's some details there on authentication. And look at the summary here. It does go into TACIS plus, and Radius. The chapter's going to go into more details about that, these directory services. Go back and review those, and also review SAML and LDAP. SAML is definitely used a lot. LDAP, these protocols are used for authentication protocols. So look into those in the chapter to give you that information that I didn't cover in this lecture. So again, and I just totally missed it, I think. We have, of course, best practices. The CISA here, the Homeland Security, we actually have, you can go here and find best practices under resources, I believe. And you can find frameworks, best practices, different business practices. If you're working with the government, definitely going to look at this. Cyber resiliency. By the way, that's the new word. It's more than cybersecurity. It's being resilient. But there's a ton of stuff here. If you search, of course, for like Carnegie Mellon, the SCI Institute, privileged account management. There's certain best practices to mitigate insider threat services. Look at this. There's a blog post. Almost too much stuff. Also, again, cheat sheets. I know I talked about some previous lectures. I can't say enough about the OWASP cheat sheets. They're fantastic. Here's an example, XML. It's going to go into integration testing. It's just how you can test and verify this stuff. It's fantastic. And NIST again. Search for authorization under NIST. Here we have something called Zero Trust Architecture. This is one of the hot new things. The idea is internally, I don't trust anybody. My file server does not trust anybody. The idea being you always assume someone's already breached the network. And so it means everything going across the wire is secure to a TLS, even internal only traffic, maybe backup jobs, for example, from a server to a backup server over a backup network. You don't assume anything is secure. And there's this whole zero trust architecture moving from us to more network-based, more focused on user asset and resource. This really does reflect the whole Mac-based. Need to know. A lot of times API servers will use this. Yeah, it's fine. I need to trust you. I don't care if you're coming from an internal IP address. I still want you to authenticate before you call this API database. But inside my database, this may be sensitive information. So again, a lot of resources out here you can use to help you figure out and best implement, audit, and verify access management. So, thank you.